Indiana University East, Stoichiometry involving compounds. So what I want to talk about in this video is how we can figure out the number of moles of a compound. And then we can look in turn into how we relate the number of atoms with the number of moles of a compound. So, as you may know, for atoms, the molar mass in grams per mole has the same numerical value as the atomic mass in AMU. And we mentioned before that for compounds, we write formulae based on the molecules, so molecular formula, or for ionic compounds, we write out the formula for a formula unit. So the lowest number combination of ions that would make up a neutral unit. And so, similar to atoms, we can define a molar mass based on the definition of how we write formulae normally, and hence any discussion on molecular mass or formula mass for a compound in AMU applies equally. You have the same numerical value in AMU as you do for the molar mass in grams per mole. So for example, for chloroform, again we add up from the periodic table. Chlorine is 12.01, hydrogen is 1.008, and carbon was 12.01, hydrogen is 1.008, and chlorine is 3 times 35.45, because we've got 3 here, and that comes out to 119.4 grams per mole. Calcium nitrite has the formula CaNO2, and so calcium we have 40.08, and then you have 2 nitrite ions, so N is 14.01, and you have 2 and that comes out to 132.1 grams per mole. So how can we use this information to solve problems? The key to this is to realize that the number of moles of a substance is directly proportional to the number of molecules and atoms present. To convert between them, as you may recall, we just use Avogadro's number. Therefore, it is often useful to just use the same relationships as we did between number of atoms and number of compounds that we did before with chemical formulae, and write everything in terms of moles. For example, in chloroform, we know that there are 3 atoms of chlorine per chloroform molecule. So we can just say that there are 3 moles of chlorine atoms per mole of chloroform. And we can do mole to mole conversion factors like this. We know that there are 3 moles of chlorine per mole of chloroform, and then we can then solve all problems in terms of moles as far as we can. As you may recall before, we convert from whatever your given units are to the number of moles of something. And then if you need to go from moles of something to moles of something else, you convert from moles of X to moles of Y, and then you go for whatever units of Y you need. Let's illustrate this using an example. How many grams of chlorine are there in 0.67 moles of chloroform? So I'm looking for the number of grams of chlorine atoms. Doesn't actually matter. And the trick to this, So here I have 0.67 moles of chloroform. And I see, as we discussed before, for every mole of chloroform, there are 3 moles of chlorine atoms. And I know that the molar mass, then I can convert the molar mass for every mole of Cl. The mass is 35.45 grams. And as a result, we have 71 grams as our answer.